Welcome to part 6 of Mathematics exam series for Victoria, Australia. In this video, we will solve the first 4 questions from a 2021 trial exam 1 paper. Hello Math Champions, I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Hello, this is the first part of a 2021 trial exam paper for mathematics in Victoria, Australia. And this is a technology-free paper. Each question you may pause the video anytime and try to do it yourself. However, I just explain every question straight away here. There are 2 equations to solve in question 1. The first sub-question is an equation with a fraction number of 2/3 as its power, while the second one is an exponential equation. Now, let's recall the factorizing formula for the difference of 2 squares. For example, the x minus 1 to the power of 2/3 can be expressed as x minus 1 to the power of 1/3, or in parentheses squared. So, the left-hand side of the equation can be factorized as the sum of x minus 1 to the power of 1/3 plus x minus 2 to the power of 1/3 times the difference of the previous 2 terms as shown in the 2 squared brackets on the screen. Then the new factor law is applied here. The factor of x minus 1 to the power of 1/3 plus x minus 2 to the power of 1/3 is set to 0, and we find the x is equal to 3/2. As for the other factor, it has no solution provided when making it equal to 0. Therefore, 3/2 is the solution for this equation. The second sub-question is to solve an index equation. Initial inspection helps us to find that the quadratic technique may be employed to solve this equation, even though it is not a quadratic equation. Here we assume y equals e to the power of 2x minus 2. So the index equation can be expressed as a quadratic equation, which can be factorized using the cross product method. There are 2 roots solved for y, which are -1 and 3. According to the new factor law, since we know e to the power of 2x minus 2 is always greater than 0, so y equals 3 is the only valid root in this case. Hence, x can be obtained by solving the equation of e to the power of 2x minus 2 equals 3. Hence, we find x equals logarithmic base e of 3/2 and plus 1. Question 2 shows a polynomial function with a fractional form. There are 3 sub-questions are asked. The first one is to simplify the polynomial fraction function. The second one is to find its derivative. The last one is to sketch the function within the interval from -2 to 3. To simplify the function, we need to do further factorization on both numerator and denominator. As it can be seen in the squared bracket, the cubic factor on the numerator can be separate to form 2 groups, while the expression at the denominator is just the difference of 2 squares, which can be easily factorized. On the numerator, after factorizing the group of x cubed plus 1 and taking out the common factor of 2x from the group of 2x squared plus 2x, there is a common factor of x plus 1 between the two groups. After taking out this common factor and collect the like terms in the remaining part, we have the expression shown on the screen. Cancelling out the same factors of both numerator and denominators, we have the simplified function shown on the screen, which is x equals x squared plus x plus 1. The value range of x is between -2 to 3, but not including points of x equal to -1 and equal to 1. Based on the simplified function fx, sub-question 2 asks us to do the differentiation with respect to x. So the differentiation of x squared plus x plus 1 with respect to x comes up with 2x plus 1. Remember, fx is not differentiable at the points of x equal to -1 and 1. As for question 3, we transform the simplified function to its turning point form, which is helpful to observe the coordinates of the turning point as well as the x-axis of symmetry, which is located at x equals to -12. Apart from that, we also need to calculate all the intercepts of x and y axis. In this case, we have no intercepts for x-axis. However, it has the coordinate 0, 1 for y-axis intercept. Here is the sketch diagram. However, since we know the domain of the function is not defined at the points of x equal to -1 and 1, so we draw two empty circles at these points that are shown in the diagram. According to the given information in question 3, the distribution of the random variable x is a binomial distribution. So the formula of the probability of achieving x successes in n independent trials can be expressed here. So px is equal to ncx times p to the power of x, then times 1 minus p, or in parentheses to the power of n minus 1. Since x is equal to 1, the equation becomes np times 1 minus p, or in parentheses to the power of n minus 1 equals 1 minus p, or in parentheses to the power of n minus 2. After the equation being rearranged, it becomes a trinomial quadratic equation with n as its parameter. So the quadratic formula can be applied here to express p in terms of n as shown on the screen. In the meantime, since the probability, which is the solution of this quadratic equation, must be in the range between 0 and 1. In addition, the discriminant of the quadratic also must be greater or equal to 0. Considering all the above constraints, we have the fractional expression of p equals the sum of n plus square root of n squared minus 4n over 2n, where n is greater or equal to 4. Question 4 is about the confidence interval for the population proportion, given the distribution of the sample proportion is known. As we have learned, when the population is large, the sampling distribution of the sample proportion can be determined by assuming that the number of favorable outcomes is a binomial random variable. When the sample size is large, the sample proportion has an approximately normal distribution. In this question, the 70 and 90% of the population confidence interval for sample proportion are given. They are from 0.3986 to 0.4104 and from 0.3836 to 0.4164 respectively. The first question is to find the conditional probability of the sample proportion between 0.3836 and 0.4164, given that the sample proportion is greater than 0.3836. The second question is to calculate the approximate sample size, given that the probability is 0.7, when the standardized value range is from negative 1.04 to 1.04. For the first question, the mean value of the sample proportion can be worked out according to the given confidence interval in the question. Here, the distribution diagram is illustrated for better observation and understanding. According to the distribution diagram, the probability of the sample proportion greater than 0.3836 is equal to the corresponding area under the probability density curve, which is 1 minus 0.05, which equals 0.95. Similar to the probability of the sample proportion between 0.3836 and 0.4104, it is equal to the corresponding area under the probability density curve, which is 0.1 plus 0.35 plus 0.35, which equals 0.8. Therefore, the conditional probability can be calculated using the conditional probability formula, and it is equal to 0.8 or 0.95, which is 16 over 19 after being simplified. According to the formula of the confidence interval for sample proportion with standardized value of z, we can calculate the sample size n from either the upper bound or from the lower bound. Based on the sample proportion diagram shown earlier, for the probability of 0.7, the value of the upper bound is 0.4104 and the value for the lower bound is 0.3896. As for the upper bound approach, we substitute the corresponding values of the sample proportion standardized values z and set them equal to 0.4104 and hence calculate the sample size, which is 2400. As for the lower bound approach, we substitute the corresponding values and set them equal to the lower bound value, which is 0.3896. Hence, we calculate the sample size of 2400, which is exactly the same as we calculated for the upper bound approach. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.